When I came to Chapel Hill in 2018, it was the first time I had lived in the South. Um, I had worked on racial justice issues in Detroit, namely the history of the 1967 uprising. Ferguson had come to pass, white nationalists had marched at UVA, and I found myself in the midst of the upheaval of the Silent Sam Confederate Monument. Sarah Carrier, a librarian at the Wilson Library, approached me about a possible new project, asking whether it would be possible to discover Jim Crow laws using text analysis. What I discovered was that someone had already blazed that path decades before, the incomparable Pauli Murray. She was the inspiration for this work, the reason I wrote, with the help of my intensely supportive then boss Amanda Henley, a grant proposal to the Collections as Data Part to Whole project, funded by the Andrew W. Mellon Foundation. On the books, in my mind, has always been an unabashed love letter to Pauli Murray. I stepped down from the project lead position in 2019, but I remain on the project as the senior advisor, uh, attending meetings every week with the rest of the team. And I left the project in the incredibly capable hands of Amanda Henley and Matthew Jansen, who remain the co-PIs. They've poured themselves into this work in a way that makes me incredibly proud. This project inspires and connects people in a way that few others do. It is magnetic, not just because of the brilliant people who have come together to make it so, because Polly's vision is really at its heart. I couldn't be happier to share it with you.
In 1950, this author and activist named Pauli Murray published a book titled States Law on Race and Color. So Pauli Murray was this incredible person. Um, she was born in 1910 to this longtime North Carolina family whose roots that Murray could trace back several generations, well back in slavery. And Murray was brilliant and a prodigy. In 1938, Murray applied for admission into the social sciences graduate program at UNC Chapel Hill, in connection to our institution. But she was denied because, as the administration stated, members of your race are not admitted to the university. In 1940, Pauli Murray was arrested for sitting in the colored section of a bus 15 years before Rosa Parks. She later went on to graduate from Hunter College. Murray earned a master's degree from UC Berkeley and later earned a law degree from Howard University, where she graduated first in her class. Um, Murray also later became the first African American to earn a JSD from Yale, and Murray also later became the first African American ordained as an Episcopal priest. Incredibly impressive person. But this book, 1950, is what I really want to focus on, the state's law on race and color. It was called The Bible of the Civil Rights Movement by Thurgood Marshall. The book itself was a collection of race-based laws across the country, not just what we know as Jim Crow laws in the South, but also civil rights laws, laws that worked on both sides of the color line. In explaining the purpose of the book, Murray called it a convenient reference guide for attorneys and a method of determining the extent to which racial practices were controlled by law throughout the country. So, as opposed to some forms of etiquette, these were actually laws on the books. So, many people, when they think of Jim Crow, they think of Jim Crow as being sort of a separate water fountain or a seat at the back of the bus. But Jim Crow was so much more than that. It was a system of racial apartheid designed to create a racial hierarchy throughout the American South. It was not only separate schools, it was, like I said, social etiquette, it was courtesy titles, it was cemeteries, it was dignity, it was opportunity, it was wealth, it was respect. It was the way that young Black kids felt when they walked out in society, realizing that they could never enter schools or playgrounds that young white kids could enter. But it was not just about these sort of basic segregation ordinances themselves. And that was part of Murray's point. So to gather all these laws to show exactly how pervasive Jim Crow actually was, to show how inconvenient these laws made life for individuals, not only for African Americans, but also white people at local on the local level. And so Murray was correct that their scope was absolutely incredible. The number of these laws is just mind-boggling. All of these incredibly complex and creative ways that people came up with to keep races separated, to make sure that every corner of the law was covered. And but of course, as Murray knew, that same scope also limited their ability to complete the task. So in North Carolina, at least 286,000 laws have been studied by our group. Roughly about 3% we think are Jim Crow laws. So Murray could not possibly catalog all of these laws for North Carolina, let alone the entire nation. And that's exactly the work that our project is picking up on here. We think we can do that. We are doing that.
So our project is a collections as data project to make North Carolina laws more accessible to scholars by creating a corpus that contains over 100 years of North Carolina public, private, and local session laws and resolutions. Our project focuses specifically on laws passed during the Jim Crow era. To create the corpus, we're using materials that were previously digitized. The volumes were digitized between 2009 and 2011 by an IMLS-funded project called Ensuring Democracy Through Digital Access. The UNC at Chapel Hill University Libraries partnered on this project with East Carolina University and the State Library of North Carolina. The digitized volumes are available in the Internet Archive. Our project will expand on this previous work by creating a plain text corpus of North Carolina session laws for general, legal, and historical research. And in addition to creating the corpus, we're also using machine learning to identify discoverable North Carolina segregation statutes from the Jim Crow era. Currently, we're finalizing our deliverables for the Collections as Data Part to Whole project, which concludes August 31st. Our deliverables include 2 text corpora, one of all the laws and one of the laws identified by machine learning as those likely to be Jim Crow laws. We will also have a website with educational materials and some context for the laws. We've already done outreach about the project to a variety of audiences. We're going to provide a short white paper that outlines our processes and our publicly accessible GitHub repository to share our scripts. And lastly, some Jupyter notebooks to help explain the scripts. Our project team is quite large. Only a subset of the team is presenting today. Team members include functional specialists from the library's Digital Research Services Department, librarians from special collections, and scholars. We're fortunate to be at an institution with the staff resources that have allowed us to bring in additional specialists as needed. We've relied on others in the libraries for their expertise in metadata, legal information, and for software development. We've also relied on student workers to assist with manual data cleaning and transcription.
Our first order of business was to compile all the volumes that we needed to process as part of our text corpus. This was about 96 total volumes spanning from the years 1865 to 1967. And we acquired the links to the digitized versions of these volumes using the Internet Archive API that gave us access to all those different URLs that we would need. But the images that we got came with a lot of challenges in terms of the OCR. So one of the most pressing was this marginalia that you see on the sides of all the pages. This marginalia does not provide new information or put the laws into any kind of context. It only acts as basically a finding aid for people who at the time didn't have access to Control F on their keyboard to find the law that they were looking for. So if we didn't remove this text before we did the OCR, it would become inserted into the middle of the text and make it pretty unreadable. And also it would end up damaging the integrity of our analysis. So another major challenge was also the fact that because these volumes spanned all these different years and they were affected by all these different changes in the printing technology over the years. So many of them have very different text printed on them, differences in the paper, in the ink, in the typefaces and the page layouts that were used. Especially in all of the images, we have the text rotated at a slightly different angle. That could have been a result of either the printing process or the scanning process, but we had to try and accommodate for all of these different challenges with the images in order for our OCR to be accurate. what we needed to do was some image pre-processing. So we created some custom Python scripts to address the challenges that we have with images. These were to remove the marginalia, to rotate the images, and then to add these color balanced margins that you can see over on the right of this slide. This directs the OCR to find where the actual text is on the page. Once we were able to do that, we also experimented with some various image adjustments to see if those would improve the OCR. And then finally, we went ahead and OCR'd the corpus. This was 80,000 pages, over 80,000 pages. But once we had completed that, of course, we needed to be able to tell how well we had done. So we were able to select a number of words at random, words that had been OCR'd, and then compare them to the actual images of those words. The OCR program we were using kept track of that information, of where those images were on the page, where the words were. And we were able to assemble this Excel spreadsheet that you see here, and got help from our students. They were able to manually assess how well the OCR did by comparing the word to the image of the word and recording whether or not it was accurate. So we found that there were a lot of different ways in which the OCR could fail. Not only could it get the word wrong, but some text was not picked up at all for whatever reason. Sometimes text got excluded because it ended up in the marginalia, or some of the pages that we were working with, a lot of the pages were full of tables of names and places and people. So those did not do very well in the OCR. So considering all of that, our total accuracy we found was around 83%, which is good for a corpus with this much variation and this much text in it. We also have a goal within this project to structure it and annotate it. And so we've done that using XML. We got the help of a metadata librarian who helped us create a metadata schema, and we wrote a script to apply the XML to all of our laws. So we plan to share the schema itself along with the XML versions of the text so that it can be used by others who might want to create their own metadata for a similar project or for state laws in their state that they might want to OCR.
Can we determine which of these laws are Jim Crow? The answer is not quite yet. So the XML scheme we just saw is kind of the goal data structure that we want to investigate these individual laws. We need to know where every single chapter and section starts and ends, because those are the distinct units of separate laws in the North Carolina session laws. So we need to take this big blob of text that we've gotten from each volume. So every volume at this point is just a continuous stream of text for the entire volume, broken out by page if we need it to be. And we need to find a way to split this into individual sections. This is a pretty challenging process in and of itself. So much like we had to do all the marginalia cleanup and various OCR pre-processing things to make our OCR go nicely, we have to do a fair amount of work here to get the splits, the laws and sections split out from these big blocks of text. We can't do this manually. There's way too much text to look at. We have about somewhere in the neighborhood of 40 million words, and we know we have hundreds of thousands of different sections. So we've developed a complicated scheme of regular expressions, also known as pattern matching, to find likely breakpoints and done some cleanup to make that kind of more usable. Then after that, we have embarked upon a cleanup process. So this involves both finding the missplits and normalizing the OCR numbers. Many of the numbers that came out of this, particularly things like those Roman numerals, came out incorrectly. So one of the key examples here is the 3s and the 8s are often confused. 5s might come out as S's, things like that. So some of these errors we were able to fix automatically, because by and large, we actually, the first pass did pretty well. So if we can see we have 12, 18, 14, we can say, well, that's probably meant to be 13. So some of these can be fixed automatically, but we also we've had to do a fair amount of work manually fixing the remaining gaps. we're approaching our analysis in two big overall heading ways. We've got supervised learning approaches and unsupervised learning approaches. The big thing that makes supervised models different from unsupervised models is that we have to have some subset of our laws labeled beforehand. So the place we started with this is extracting the laws identified by the previous work of chiefly Polly Murray, and also we found another scholar, Richard Pascal, who have done projects in the past to identify Jim Crow laws in historic North Carolina laws. So both these scholars gave us this great foundation to build upon. However, both scholars focused very rationally on identifying Jim Crow laws and not on giving us lists of things that had been labeled as explicitly not Jim Crow laws. So unfortunately, our model needs both types of law. It needs to have some examples of what a Jim Crow law looks like, and it needs to have examples of what non-Jim Crow laws look like to best get the distinction between the two of them. But as soon as we had initial split out laws, we provided random subsets of these laws to our project team's experts. That's William, who you heard from earlier, and Kimber Thomas, who is another scholar in American Studies and African American Studies. We are currently focused on using a few different types of models for this. So as a baseline, we're using multinomial naive Bayes. We're using various other types of ensemble models to classify these. So ensemble models as a general class are types of models that fit lots of small, relatively simple models, and then bring together this whole population of little models in a complex way to create a single, very powerful classifier. So between these different types of ensemble models and naive Bayes and different representations as well, we will be looking at a method to evaluate these models by splitting up the data, the training sets, so the labeled laws, so that we have some observations that the model uses to fit, and we have observations that the models have never seen. So we can evaluate how these models perform on laws where they don't already know the labels. So we can have a phenomenon called overfitting, where we really fit in too tightly on this example data that William and Kimber and Polly Murray and Pascal have provided for us. And we may not perform very well in the rest of the corpus. So we really don't want to fit too tightly to the data. We want to get generalizable results as best we can. Because these laws are relatively rare in the corpus, as William said earlier, we may only have about 3% of the laws that have some Jim Crow element that we can detect. We won't just use simple classification accuracy for this. Real easy motivation for that is anytime you have a really rare outcome, if you have a rare phenomenon, you have a volcano eruption or something like that, you can be a really accurate predictor by saying that is never going to happen. If it only happens 1% of the time, then if you say it's never going to happen, you're 99% accurate. But we don't want a model like that that's really accurate, but is generally just telling everything it's no. So we're really attuned to that in terms of choosing our models. Under unsupervised modeling, we will use some unsupervised models to explore the corpus in a more general sense than the supervised models. The unsupervised models will attempt to basically find general patterns in the data set. So we're going to group the data set into different clusters or categories. A really common example of this is topic modeling. You can see here that these topics are just kind of lists of salient words that are associated with the topic. So any given law is generally thought of as a mix of topics. So it's going to, one of the things the model will give you is a proportion from each of these topics that each law was kind of thought of as coming from. All of this analysis will take place in Python, just like the marginality and OCR stuff that Lauren talked about a moment ago. When we're done with this project, we will be sharing all of our underlying code, and we're going to do that with Jupyter Notebooks. So this is a very small snippet from part of a Jupyter Notebook. This shows a part of the banding process that was used to identify the marginalia. So you can see here we have at the top of the screen, we have some just plain English talking about images. These images describe the banding process. It's referring to objects that are part of the code. So it's kind of in direct interplay with the code. We have a small block of code here, and then we have the images themselves. So this is an example of what's called literate programming. The idea here is we combine the computer code with plain English, with these graphics, so that a really wide audience can find something to grapple with here. If you don't know anything about code, you can still read the English, understand what's being talked about, see the images of what's going on. if you are looking at this, trying to adapt it to your own code, you can better understand why we're doing what we're doing.
We are teaming with an initiative at UNC Chapel Hill called Carolina K-12. They provide professional development programs and training to public school teachers in North Carolina. They are teaching experts, they are curriculum experts, they build original lesson plans on a variety of subjects, and they have a database through their website. So we are teaming with them to build lesson plans around Jim Crow in North Carolina using the laws that we identify at the core of that. The education module will have resources for teaching and learning. Included will be a glossary, a timeline, a list of primary and secondary sources, and links to these Jim Crow lesson plans. The website is under construction. It's going to be a WordPress platform. We built and are building this site for a real diversity of use cases and audiences, digital humanists, teachers, students, historians. So we're really trying to think about the different components of the website that would be useful. So we'll have the education module. We'll also have the actual corpus. We'll have the inventory of Jim Crow laws there. We will be publishing a white paper that will be available on the site. So the site will have lots of information for researchers, all kinds of scholars who want to replicate our work or do something very similar. As Matt was talking about, we will have a GitHub code repository where the Jupyter notebooks will be available explaining the code. And we have been and plan to continue doing a lot of outreach to a variety of these different potential user communities.
Given the place we find ourselves in 2020, I hope you find some animating force within On the Books, Jim Crow and Algorithms of Resistance. In the introduction, I mentioned Pauli Murray, but I would also be remiss if I didn't mention this project's second inspiration, Dr. Safia Noble, who described the danger of algorithms in her book, Algorithms of Oppression. From the start, this project has been concerned with the social issue of algorithms. They have become a social problem to the extent that we use them for personal benefit. In the broader sense, this project grapples not just with racial injustice, but with trying to answer a fundamental question in the 21st century. If there are algorithms of oppression that hurt society, can there also be algorithms of resistance that expose and fight injustice? Creating algorithms of resistance is our greatest goal.